Hello dear aspirants, welcome to GDC online classes and I especially welcome you for my pharmacognosy sessions. Yes my dear aspirants, in the last session, up to the last session, we have covered quinoline alkaloids, up to quinoline alkaloids we have covered. In this session, we are going to cover the rest of the alkaloids and then we'll start with isoquinoline. Yes, I said that. Before in the previous classes, I said that yes, we are classifying the alkaloids based on their nucleus and based on their chemical nature, so that we have covered so many things. Now we are going to see what are the alkaloids which are consisting of isoquinoline nucleus. Because of that nucleus, every nucleus, we knew that in your pharmaceutical chemistry, especially in the medicinal chemistry, we knew that a thing called SAR, a structural activity relationship. Which why I am mentioning this thing in this particular pharmacognosy, because our subject is pharmacognosy and phytochemistry, where it deals with as like in SAR, structure activity relationship, because of the para or the meta positions and by the substitution of withdrawing groups and donating groups, based on the structure activity relationship, based on the changes in their positions, it may have a different properties, it may have different pharmacological action as like the same scenario. Because of the different nucleus in these alkaloids, they are having different types of properties. As like that, if you see the tropane alkaloids, the tropane alkaloids will possessing the anticholinergic property, muscarinic property. So for that reason, and coming to the pharmacognosy, while you're reading about the pharmacognosy, you should definitely know what is the nucleus of the particular alkaloid and what is the function of the particular nucleus, what is a specific pharmacological action that they were possessing because of that nucleus, and also what is the occurrence and what is the distribution of these specific type of alkaloids in specific families. Yes, whenever you're going through all these alkaloids, whenever you're going through all the glycosides, you should definitely know about what is the nucleus that they are containing. So because of the nucleus, what action that they are producing. Clear? Yes, that's the beauty of the pharmacognosy. We'll see isoquinoline alkaloids. So these are the alkaloids characterized by the chemical structure containing isoquinoline ring system. Isoquinoline ring system that we have seen in the previous slides. And these compounds widely distributed in the various families like Papaver, Ranunculaceae, 𝘂𝙬𝙎, and Rutaceae. So my dear aspirants, while you are going through the isoquinoline, any of the secondary metabolite, should also check the holistic approach in which families, in which species they are abundantly grown, they are abundantly seen. So that reason I have included that the families of the particular type of alkaloids. You should definitely go through that. You should definitely, whenever I say tropane alkaloids, your mind definitely should think of the Solanaceae family, like how the rest of the alkaloids should have a specific chemotaxonomical aspect. Yeah. Yes, so they are rich in Papaver, Ranunculaceae, 𝘂𝙬𝙎, and Rutaceae. So we can abundantly see, if you want to prepare, if you want to get isoquinoline alkaloids, then you definitely go through all these families so that you can get these isoquinoline alkaloids. Okay, yes, and also they are possessing some of the pharmacological and biological activities in such medicine fields like medicine and pharmacology. Yes, we'll see what are the drugs that we are having in the isoquinoline alkaloids so that you can understand. We knew that the best example for this isoquinoline alkaloid is opium. Whenever the opium, I think your mind should definitely goes on to a word called CNS depressant. It is a narcotic substance which causes sedation to your brain, which acts on your CNS. Okay, so that you should definitely remember any compound. Whenever you look at it to any compound, definitely your mind should think of the specific uses so that you can get other interlinks. Okay, opium. So opium, yes, we have seen that. So where did we get this opium? Whether it is a leaf or bark or fruit or stem or rhizome or any other flower? No. It is an unorganized drug. It is an unorganized drug. Why it is meant to be unorganized drugs? Because it is not at all obtaining from, it is not possessing any cellular structure, which means it is in dried latex or gum latex. You can see right over here, the person who is holding this opium poppy capsule, he was scraping off with his like spatula like substance. That was scraping. What was the thing he was scraping for? Right over on the surface of the capsule. He made some incision, and after that he could collect the gummy latex, that is an opium, raw opium, a milky exudate or milky gum latex. Okay, so it is an unorganized drug, isoquinoline, especially the opium. It is collected from, it is obtained from the dried latex obtained from the incision of unripened capsule of Papaver somniferum. Papaver somniferum. Even though we are having three sources, but rich higher amounts will be accountable for the Papaver somniferum. Coming to that, synonym. The synonym is a very important when we read about pharmacognosy. FM. Okay, you can definitely remember that opium, poppy, gum latex. You definitely remember. That's easy to remember. But then any type of special cases or special synonyms like FM, devil's dung, like associated the devil's dung. So you should definitely remember that. FM is a synonym for opium, and whereas source is obtained from the dried latex. It is a dried latex. That's the reason it is a gum latex and opium poppy. Okay. Mostly the major amounts can be collected, the opium alkaloids can be collected from the Papaver somniferum, but whereas other varieties where they can have these opium alkaloids or isoquinoline alkaloids or Papaver somniferum album, that is an Indian opium, Papaver somniferum glabrum, that is a Turkey opium, whereas the Papaver somniferum nigrum, that is a European opium. So you can use these varieties in such conditions like substituents also. They can also use as a substituent for these Indian opium. Whenever there is a lacking of these Indian opium, they can substitute with these things. So they can adulterate with these things. But we can't assess or we can't confirm, we can't assure that the same amounts of alkaloids will be present in the same species, all the rest of the species, that is glabrum and nigrum. Clear? But the major source is like Papaver somniferum. Belong to the family Papaveraceae. Family Papaveraceae. We knew that. And whereas coming to that microscopy, so what is the microscopy of this opium poppy capsule? Because even though, why we need to remember the microscopy, sir? Because you are saying that it is a dried latex. We are not depending on any of the things. It is a dried latex that you are saying. Yes, even though the same opium poppy capsule may be available in two other species like glabrum and other sources, European and Turkish capsule. But we only get the exact opium amount, opium alkaloids from the Papaver somniferum. Papaver somniferum. So that we will see what is the microscopy of Papaver somniferum. It shows, the microscopy shows agglomerated latex granules when you dissect. You can see the agglomerated latex granules in irregular mass, and it is consisting of anamocytic stomata. So if you see anamocytic stomata, any one of them, from any one of them, then you should confirm it is an Papaver somniferum, which consisting of opium alkaloids. And pointed trichomes with a few starch granules are present. So these are the characteristic features of the opium or the Papaver somniferum. And whereas coming to that chemical constants, we very well know about the chemical constants of opium, that it's producing several alkaloids like all the narcotic substances. There are about 90% of the alkaloids that are narcotic substances are only thoroughly synthesized by the opium only, the opium extract. Okay, so that opium alkaloid derived from amino acid and phenylalanine tyrosine, which means 𝘂𝙀 acid pathway. So there is chance of asking questions like opium or isoquinoline alkaloids can be obtained from which pathway? What are the precursors for the isoquinoline alkaloids? Yes, definitely should think of the name called phenylalanine tyrosine, which are seen in the 𝘂𝙀 acid pathway. Okay, and when the present alkaloids combined with organic acid called mechanoic acid. Yes, I said that. Meanwhile, we are reading about the alkaloidal introduction. These alkaloids may be present as a free salts of organic acid or maybe free bases. Okay, but you should definitely think of that. Most of the alkaloids will be in salt forms, especially they are combined with any of the organic acid. Especially in this opium alkaloids are combined with an organic acid called mechanoic acid. Yes, maybe there is a chance of asking a question from which of the following organic acid is a combination or present in the opium alkaloids. Mechanoic acid. You should remember like opium, M. Opium is ends with M, and the other alkaloids obtaining from the opium is morphine. Okay, so mechanoic acid, opium, M, it ends with M and starts with another organic acid called mechanoic acid. Okay, I should should remember like that. Opium alkaloid. So what are the opium alkaloids we have? We have, especially in the opium alkaloid, we can categorize based on the nucleus two types. That is, one is benzyl isoquinoline type of alkaloids and phenanthrene ring alkaloids. Phenanthrene ring alkaloids. In that, benzyl isoquinoline, these are NPN. NPN, isoquinoline, NPN. Okay, so narcin, narcotin, papaverine. So these are the benzyl isoquinoline. So then maybe they ask like, so what are the benzyl isoquinoline present in the opium alkaloids? Undoubtedly NPN. Okay, NPN, narcin, papaverine, narcotinone, noscapine, also known as. Okay, and whereas phenanthrene containing opium alkaloids are morphine, MCT, codeine, thebaine. Morphine, codeine and thebaine are consisting of phenanthrene nucleus, whereas these are benzyl isoquinoline alkaloids. So these are the major chemical constants that are present in our opium plant. And next to that, apart from that, this morphine, coming to that properties, if you look at the properties of this morphine, because the morphine is a chief constant of the opium, it is a monoacidic and levorotatory when it chooses optical rotation. When you look at the optical, it is levorotatory phenol alkaloids, and also contain alcoholic hydroxy group at their 6th position. At their 6th position, alcoholic hydroxy group. Okay, so that's alcoholic hydroxy group right over here. Okay, so like in that position in generally. Okay, so that's they possessing the alcoholic hydroxyl group at 6th position, C6 position, and also they are present, opium alkaloids present as a mechanoic acid, salt of mechanoic acid, like this. Okay, salt of mechanoic acid, that's what I said. Alkaloids will be available as either the free salts of organic acid or free bases. Okay, and opium also contains some other chemical constants like sugars, waxes, mucilage, and salts of calcium and potassium and magnesium, because it's a latex, contains a waxy material, and you should have some carbohydrates, sugars, and mucilage. And when you look at these other chemical constants, especially from the morphine, we can synthesize the codeine, and from the codeine we can develop the thebaine because of the subsequent reactions. Clear? So these are the chemical constants of the opium. Then we look to the other important things or the uses, other species. You can see that upon some of the reaction, upon the methylation, we can get methyl morphine. And if you add some other COCH3 groups, okay, 2 COCH3 groups, then we can get heroin, and upon hydrolysis we can get apomorphine. So that based on subsequent them subjecting them to other reaction, we can get a synthesize other products like methyl morphine we can get from morphine, and heroin we can get from morphine, and also we can get the apomorphine from the morphine. Okay, and this is structure of mechanoic acid, and this was a structure of papaverine. So this was a basic nucleus, and which is consisting in the opium. And coming to that, what allied species that we have seen, the papaverine bracteatum, so contains no morphine, and it contains high percent of thebaine, so causes no addiction, because so that it will be the other allied species. Okay, so in this only thebaine is present, there is no other chemical contents of opium are there. That means that leads to no addiction. Next, the main important thing in this alkaloid, especially the opium alkaloid, is uses. We knew that they are acting on our CNS, especially they act as narcotic substance, but apart from that, it acts as an analgesic, and also used to and produce a respiratory depression and constipation. It can produce some other pharmacological activities like it reduces respiratory depression and constipation. It sometimes causes. And coming to the other chemical constants like codeine, it relieves the local irritation and bronchial tract, and as an antitussive used in the various cough medicine. Yes, codeine is a codeine cough. Okay, so codeine refers to and is used as a cough preparation. And whereas the papaverine has relaxant effect on smooth muscle, papaverine on the intestinal line, bronchial tract, on the blood vessel. So they're depending upon the cases or situations, they use a papaverine. And apomorphine is used as a emetic. Okay, so emetic for treating the poisonous cases. And whereas the narcotin has a specific depressant action on cough reflex and used in the preparation of cough lynches. Okay, so narcotin and codeine are used as a bronchial preparation, sorry, cough preparation. The rest of the things have this specific actions. Please do remember all these actions. That will be helpful for you to understand and to answer all the questions based on the uses. Now, the last and important thing in this OPM is identification. Identification test of OPM is a very important thing when we discuss in regards of the examination. Yes, OPM when it is treated with a ferric chloride solution gives a reddish purple color. Reddish purple color. Upon the color passes even upon addition of the HCl. Even after the HCl, it passes the reddish purple color. And morphine when it's sprinkled on nitric acid, it gives a orange red color. But whereas the codeine does not respond to this test. Okay, so opium upon with FeCl3 reddish brown color, and same as well as a morphine when it's treated with nitric acid, orange red color is produced. And the morphine with potassium ferric cyanide and ferric chloride gives a bluish green color, whereas the codeine does not respond to any of the tests. And whereas the papaver solution HCl and treated with potassium ferric cyanide, it gives a lemon yellow color. Yes, this test was asked in a GATE examination, 2006 examination. Okay, so somehow they ask about the test. Coming to the names test, Marcus M morphine. Marcus test is for morphine identification test. Should definitely remember that. And morphine plus concentrated H2SO4 and formaldehyde gives a dark violet color. Morphine, Marcus test with formaldehyde, MMM. Marcus, morphine, maldehyde, which means formaldehyde, gives dark violet color. You should have that own approach to remember all this identification tests. Okay, yes, that's about the isoquinone alkaloids. Especially the one important thing is OPM. Please go through with the OPM so that you can definitely have a good idea, good marks. You can get good marks from the isoquinone alkaloids. Now we are moving to that indole alkaloids. We know that. I think you definitely think of that indole alkaloids. It contains an indole nucleus. Okay, but when I ask you about what is the example for indole alkaloids, you definitely think of that 𝘖𝙗𝑃ine and vinca is the best example. Indole alkaloid, indole nucleus containing alkaloids. Okay, we'll see what are the other indole alkaloids. Okay, coming to the first and foremostly, apart from that 𝘖𝙁, we are having apart from vinca and all this, 𝘖𝙁. So with respect to the examination, the 𝘖𝙁 is a very important topic. Either because it includes its life cycle, and if you observe the rest of the things, it has a role. Almost all the alkaloids are obtaining from any of the plant source, but it is directly obtaining from the fungus. So that unique differentiation it had from the other rest of the species. Okay, we can get the alkaloids from plant leaves, roots, stem, and any flowers. But when we look at the 𝘖𝙁, it has a unique approach. It has a unique source that it is obtained from the fungus, living organism. Okay, so we'll see that synonyms of this 𝘖𝙁: Saint Anthony fire and 𝘖𝙁 of rye. So this is the Saint Anthony fire, and it is mostly affected on the rye or grains. Okay, so 𝘖𝙁 is a dried sclerotium of fungus. Sclerotium, the outermost layer, the bluish or the purple to dark brown color. Because I'll simply conclude that it is a fungus which is developed on a cereal plant. There is a graminae, especially on the ovary of this particular plant is fungus, that is Claviceps purpurea got affected, and it can develop the sclerotium, the outermost protective layer. We can consider as the outermost layer. So after complaining, after considering, after carrying, after going through all the cycle, this sclerotium got covered. This sclerotium has developed, and after the several reactions. Okay, Claviceps purpurea. So simply you should remember that this is a fungus which is responsible for to develop the sclerotium on the plant, on the ovary of the rye plant called sickle cereal. So you should definitely remember. So this is a sclerotium which is affected on the ray plant seed. Okay, so granule, the ovary of the particular kale and cereal plant got affected by the Clavus purpurea and produces a black. So these are all the blackish brown color. These are all nothing but the sclerotium. Okay, so these are the sclerotium. We'll see the life cycle of the ergot because it's a very important thing. It has three stages, especially the ergot life cycle has three stages. One is a spatial stage or honeydew stage, which produce a sweetest M or sweetest compound, which in order to attract the insects and other fungus. And sclerotium development stage and ascospore stage finally develop some spores. Okay, so this was a diagrammatical or schematic representation of this life cycle, where firstly the ascospores are developed. This first in the final step. In the first itself, the grass or cereal flowers, the grass or scleral flowers, when it produces a scacilia or a honeydew like substances is produced on the grass of cereal because of the infection caused by the Clavus purpurea. So to that of the cereal flowers, and because of they got infected with the Clavus purpurea, and they produce a honeydew form or the Quinidian honeydew, which means a spacilia will be developed. So then after that, this cereal head with sclerotia. So then it's after affecting that, after formation of this honeydew, and later on that these cereals on this ovary, it produces some sclerotia. Initially it produces a cereal head with nothing but initially they forms a head. Okay, so on the cereal, on the ovary, on the seed, initially on the top of the position they produce a cereal head which have affected with sclerotia. Then after the summer, the sclerotium vernalization was started. Then after that, in the early spring season, it causes a stroma carrions of meiosis, and finally peritheca with acid, and finally it produces ascus. Simply I'll tell you that. Firstly, the cereal plant got affected or infected with the Clavus purpurea, and later on the seed, on the cereal head, it minutely produces some sclerotia that ergot. Okay, then the sclerotium vernalization or development replication of this will be happened in the summer. Then after the summer, in the early spring season, it produces the ascospores. So this ascospores will leads to the thing. Clear? Yes. So we'll in the systematic stepwise we'll understand this life cycle. Spores of fungus called as ascospores. So these spores gets infect the plant by insect wing to the flower of ray, and these spores germinates and form the hyphae strands and penetrate into the ovary. So these ascospores, initially that ascospores will affect the graminae or the particular cereal. So thereby causes the infection on the enzyme, and after that it penetrates into that cereal, and then after that it forms a white mass called a sweet substance called spacilia, that is a honeydew product, and the further hyphae invade into deeper, then directly then after that, after producing this spacilia, it directly invades into the ovary of the particular seed. Then it causes a pseudo-parenchyma, that is a purple color outermost layer that we seen in the seed. Okay, ascospore will be causing or got affected onto the on the cereal that got penetrated with the help of an enzyme. Then after the enzyme, it produces a white mass substance called honeydew, and then after that it continuously invades into the deeper of the ovary. Then it finally produces a pseudo-parenchyma, that's a purple color substances, and this purple color substance called sclerotium. So this is sclerotium. So this is a sclerotium. This is a sclerotium, the dark color substance. So that sclerotium is collected, and then from that sclerotium we can get the ergot. Okay, some sclerotia are not collected and fall onto the ground, and these sclerotia produce a next year stomata. So each stomatum has a globular stalk head like how. Okay, and the head portion contains a large number of perithecia, and every perithecium like a flask head structure which contains a large number of sacs, and each sac contains many ascospores. So this is ascospore containing compound. I'll simply tell you that firstly an ascospore will be there. So this fungus, the spores of fungus will infect the ray plant or flower of the ray plant. Then after that, this ascospores will germinate and forms a hyphaid stand and penetrate into the ovary, and they produce a honeydew substances, a spacilia, which is called a honeydew product. Then it invades deeper into the ovary of the particular cereal, and it produces a pseudoparenchyma that is called purple color substance. And thus after the process and after several days, it can produce a called sclerotium, that is a brown color or to purple color. That from that sclerotium we can separate their ergot, that is Clapsis purpurea, that can be used for the medicinal purpose. Okay, yes, so that finally it produces some spores that is called ascospores. Okay, so that's about the life cycle of the ergot. But coming to that, what are the other important things? We need to look at the microscopy of the ergot also. The sclerotium is made up of thin flattened polygonal cells. So this is a direct or the zoom or the 3D image of the cereal which is got affected by the sclerotium. Okay, so this sclerotium, the outermost purple layer, purple to dark brown color layer, it is kind of thin and flattened polygonal cell substance, the pseudoparenchyma, that's we discussed, right? So that is made up of thin flattened polygonal cells, and inner part of is made up of dense pseudoparenchymatous cells made up of chitin, and it's consisting of mycelial cells present contains a fixed oil. So it consists of fixed oils in this all the structure, and this sclerotium does not contain starch and other calcium oxalate crystal or any of the lignified tissue, because this sclerotium is developed by the fungus, not by means of the plant. Okay, so that's about the microscopy. And coming to that, main important thing is chemical constants of the ergot. So it contains about 0.1 to 0.25% of indole alkaloids, which are derivative of lysergic acid. Yes, you should definitely remember that. So from which precursor we can get the ergot? From the lysergic acid. And also it contains the pigment of ergosterol and fungisterol. Consist. But coming to that, based on their solubility, based on their rotation, optical rotation, we'll have several type of alkaloids from the opium. Especially come to the water soluble alkaloids from the ergot. They are levorotatory are as well as water soluble, and as well as levorotatory are ergometrin, that is known as ergonovine. And whereas the water soluble but dextrorotatory is ergotamine. And whereas water insoluble substances are very important, they are levoactive or ergotamine, ergocryptin, and ergocornine. And whereas the dextrorotatory are ergocrystinin, ergocryptinin, and ergochromaninin. So these are based on the solubility as well as their optical rotation. And also some of the exceptionals and their uses, especially the main important prominent alkaloids are ergometrin, which is a oxytocic purpose or constrict the uterus, oxytocic purpose, and it constricts the uterus, and sometimes used as a enhance the labor pain in the delivery cases. So it is used as a, so that ergot from the especially ergometrin, okay, used to enhance the labor contractions in the delivery cases and to prevent the postpartum hemorrhage, and after that to prevent the postpartum hemorrhage. And also the ergotamine used in the specific analyzing and treatment of migraine. Yes, so this is a main thing. It's a very common use. Ergot is, especially when we look back, very common uses. When you talk about the common uses of some plants and we consider that condition, ergot is having a migraine. It is prominent because of the it is used so many days from the because of the use of migraine. And ergotoxin, it is used in the geriatric patient. So these are the chemical constants. And the last is identification test. The very important test with respect to the ergot is Van Eyck test. That's a common test and what is an important test. And this ergot powder gives a blue color with p-dimethylaminobenzoate. It is a Van Eyck reagent. Gives a blue color. If it is produced a blue color, so that will be the ergots, true ergot, and failings failings 1 and 2 days to the solution of carbohydrate, the equal quantity of A and B are added, and after that we know that the failing A agent, failing test will produce a brick red color precipitate. So if it is produced, the ergot is confirmed. Iron 3 chloride test, and whereas the hydrolyzable tannins are soluble in water and their solution produces a blue color with ferric chloride. Yes, with the iron 3 chloride solution, if it is produce a blue color, then it will be ergot. And fluoroglycerol in HCl, because the lignified tissue stains with fluoroglycerol and hydrochloric acid. Yes, if we place onto that of the particular sclerosium, if we see the lignified tissues, then it will be confirmed as a ergot. Yes, my dear students, this is about the ergot. You should definitely know about the life cycle of the ergot and the chemical constituents of the ergot and their uses and the chemical test. So this is for today. We'll see in the next session. Until then, have a great day. Thank you.